We are on slide number 5, and in this particular slide, I'm presenting the kind of a QoS that WiMAX 16E supports, and what kind of applications that can be used in those particular QoS. Essentially, WiMAX 16E has support for 5 a layer of QoS. Those are called UGS, unsolicited grant services, and then the next one is called ERTPS, an extended real-time packet services, and then we have another QoS called real-time packet services, and then non-real-time packet services, and the last is called the best effort. So UGS category is normally used for TDM and voice over IP links, and whenever there is a UGS supported over a service flow, then it is guaranteed with bandwidth and has lowest latency and has minimal jitter. ERTPS toggles between UGS and RTPS. It has an applications for voice. RTPS schemes are used for streaming audio and video, and also gaming applications, and has low streaming latency and also has a low jitter. Enterprise data or FTP kind of an applications normally used in an RTPS and has prioritized traffic and control latency. And the last is the best effort, which is the lowest in priority and normally used for web and data traffic, which is HTTP traffic, and has the lowest priority, and it can be capped to certain extent. In slide number 6, and an end-to-end view of the QoS mapping is presented. So most of the time we have open-ended questions like how do we ensure data security between and QoS between mobile stations to the internet, guaranteeing QoS between home locations to a branch location over an enterprise traffic or an retail traffic. So in the left hand side, you can see the laptop or the mobile station connected to a base station over 802.16e air QoS, which are either UGS, ERTPS, RTPS, and RTPS or best effort, and from the base station to an ASN gateway, there is an IP network or an IP cloud, and the base station and ASN gateway has an GRE tunnel for each connection. So between air interface between mobile station and base station, one of the air QoS can be used, and between base station to ASN, one of the IP QoS can be used. Most commonly one used are the diffserv DSCP bit markings, and between ASN gateway to home agent there is a tunnel called mobile IP tunnel, and this tunnel can also use an diffserv based queuing or scheduling. So end-to-end delivery of QoS is possible in 16E network, and in this particular slide it is presented that we can prioritize data coming in air through WiMAX air QoS, and in the core through an IP diffserv based markings. In slide number 7, applications which can be given in priority over air can be mapped to an IP QoS is presented. So for example, if you have a voice over IP application which requires a real-time communications with very strict delay and requirements, then over the air we can map it to an UGS or ERTPS QoS, and over the IP and DSCP bit marking of EF can be applied. So for example, if you have an enterprise data that needs to be given a priority over an retail data, then over the air we can map it to an RTPS flow, and over the IP we can map it to an AF3 DSCP bit marking. So pretty much all type of applications, be it multimedia conference or game or video on demand or retail data, can be mapped to an over the air QoS, and then it can be mapped to an IP QoS to deliver an end-to-end quality of service to our customers in mobile WiMAX. In this particular slide, WiMAX scheduling is explained, and on downlink, base station decides downlink allocations for user based on QoS parameters which are related to a downlink connection identifier. So So for example, if a base station wants to schedule a data to a mobile station will report channel condition on the feedback channel, and the base station will decide the downlink allocations based on the QoS parameter. The scheduling algorithm is implementation specific and depends upon operator's requirement and supplier's recommendation, but commonly used scheduling algorithms are like fixed scheduling, deficit round robin, proportional fair, etc. So um, in my observation, proportional fair is more suited for mobile best effort data, and the deficit round robin or fixed algorithm is more suited for enterprise or fixed kind of a deployment. If the base station supports ARQ or HARQ, or in the transmission if ARQ or HARQ is used on the connection, the mobile station sets ACK or NAC to the base station. So this one summarizes the pretty much the downlink scheduling mechanism. Uplink has a different mechanism. So in uplink, allocations differ for different service classes. So depending on the service class, the base station uses unsolicited bandwidth allocations, polling, or contention. So for example, if you have an UGS service given to a user, so then the base station will give him a periodic request without any contention or polling. Or if you have an RTPS assigned to a subscriber, the base station polls mobile station periodically based on the value in the QoS parameter. If you have an enterprise data, or if it is mapped to an RTPS, the base station polls the mobile station as often as possible every 1 second to allocate bandwidth. And finally, if you have an best effort allocation to a user, then all the base station can poll for best effort connections. This connection has lowest priority and can use contention for bandwidth request. So in nutshell, downlink allocations are based on the channel conditions and QoS parameters, and uplink conditions or uplink scheduling is based on service class that is being assigned to a subscriber. Mobile WiMAX has advanced air link control mechanisms, and we will briefly see some of the advanced air link mechanisms, which are ranging, CQICH, HARQ, link adaptation, and power control. Ranging is used to do a synchronization, and when a mobile station does a ranging, it adjusts its frequency, time, power offsets, etc. CQICH feedbacks provide fast feedback from mobile station to base station. It also provide feedbacks about HARQ, FBSS, etc. ARQ and HARQ are methods that supports simple layer 2 air link control and layer 1 link air control error controls. It actually enhances reliable link over wireless channels. Link adaptation is a method to adaptively select coding and modulation schemes in mobile WiMAX, and power control is supported in mobile WiMAX, and both type of power control, uplink and open loop and closed loop is supported. So we will see one by one all the advanced air link control mechanisms supported in mobile WiMAX. The first is ranging. Subscriber station contention accesses with CDMA ranging code, and base station directs closed loop adjustments based on frequency offsets, and it also gives directions for time offsets. It also gives a direction for power offsets, and allocates and bandwidth allocations. Types of rangings are initial ranging, and then there are also handoff rangings, and then there are periodic rangings, and there are ranging for bandwidth requests. So the ranging is an important step in mobile WiMAX and network entry procedures, and due to the TDD nature of the systems, very strict frequency and time offsets are required, and